Next we will see this topic called equation of line passing through two given points. Previously what we saw was if we had a point and we had a vector, how do I get the equation of a line which passes through this point and is parallel to this vector, right? So this is something like your 2D straight lines, where what we saw was there are various forms of writing the equation of a straight line. One was the slope point form. So slope point form, where you had one point given, and you knew the slope of the line, you could write the equation of the line. And this case is very similar to this 3D case, where you have one point given and you have a vector. You need to find the equation of a line which passes through this point and is parallel to this vector. This case is very similar to your 2D case, where 2D case of slope point form. The second case in your 2D straight lines was 2-point form. It was 2-point form. So you had 2 points with coordinates x1, y1 and x2, y2, right? How do you get the equation of a straight line which passes through these 2 points? That is what your 2D case was. Now this case is very similar to this second 2D case. So here also I have 2 points and I need the equation of a straight line which passes through these 2 points. So let me see how I'll get it vectorially first, and after we see vectorially, then we will see the coordinate or the symmetric form. So what I will do is I will first construct this origin, and what I will get is the position vector of this point, and this position vector is a bar, right? Let the position vector of your point A be a bar. Similarly, the position vector of this point B, it is b bar, right? It is b bar. Now what I need is this straight line which passes through these 2 points, right? The straight line which passes through these 2 points. Now what you can see is this is very similar to the previous case, just that here what I have is 2 points instead of 1 point, right? To write the equation of a straight line, I just need two data, right? 2 data. Either I should know its slope in 2D or its direction in 3D and point, right? Or I should know 2 points, right? In both cases, I can, if I know any of these two cases, I can write the equation of a straight line, the equation of the required straight line. So now what we will see is how can we write the equation of this straight line. So once again, what I will do is I will use the triangle law. So I need this, let this vector be, this vector is a bar, this vector is b bar, and this vector, this blue vector is your ab bar, right? So before writing the equation of a straight line, what do? We take a general point on that straight line. So what I will do is I will take a general point called P on the straight line, and the position vector of this point P is r bar, right? So you start from here, you go to this point P, right? So let me use the same color. So you start with this and you go to this point P. Now as you can see, OAP is forming a triangle. In this diagram, just have a look at OAP. It's forming a triangle. Now I want to make sure that it forms a closed triangle. So what I will do is basically your OA bar, which is this pink vector, plus AP bar, which is this part, right? The vector which goes from here to here, AP bar, right? Plus your PO bar should be 0, right? So this way, and this way. This is your OA bar, this is your AP bar, and this is your PO bar, right? Because this was your OP bar, so obviously this will be your PO bar. So now these three should add up to 0. That is coming from your triangle law. So with that done, what I will do is I will now substitute the values. So OA bar is nothing but your A bar. What is your AP bar? Now it's actually very easy to write AP bar, because what you will do is AP bar is nothing but OP bar minus OA bar, right? It is nothing but OP bar minus OA bar. So plus your PO bar is nothing but minus B bar, and this is equal to 0. Now the thing is, this vector OP bar minus OA bar, which is this, is collinear to your vector AB bar. So as you can see, I'll just draw it here with a different color. This vector AB bar, which goes like this, and your AP bar are collinear to each other. They're pointing in the same direction. So obviously they can be related by some lambda. So I'll write A bar plus OP bar minus OA bar can be written as lambda into OB bar minus OA bar. Right? What is your OB bar minus OA bar? It is nothing but lambda into AB bar. Right? Lambda into AB bar, and this minus B bar will be there as it is. Sorry, this is not your minus B bar. This is your R bar. In fact, it's your minus R bar, because your OP bar is R bar, so PO bar will be minus R bar. This is your minus R bar. Lambda into AB bar is equals to, I'll take the minus R bar, that's in, this is your R bar. So R bar is equals to A bar plus lambda into AB bar is nothing but OB bar minus OA bar. That means it is B bar minus A bar. So this is basically the vectorial form. This is the vectorial form of the equation of a straight line which passes through 2 points. So this is your vectorial form. Now, if you have a look at this expression is very similar to your previous case where it was 1 point and direction form. So this is one of the 2 points from which your line passes, and this B bar minus A bar is the direction, right? It is the direction. So the previous case where you had a point whose position vector was A bar, right, and it was parallel to a vector B bar, the equation of a straight line R bar was A bar plus lambda B bar, where this was your point and the one next to lambda was your direction. Here also it's very similar. This is your point. Instead of A bar, even if you write B bar here, it won't make a difference because it will still be right. This is A bar plus lambda times, and then this B bar minus A bar is giving you the direction of this line, because B bar minus A bar is this vector. So this vector is obviously parallel to your line, because your line and this vector are pointing in the same direction. So obviously this is R bar equal to A bar plus lambda B bar. What is this R bar here? So basically R bar represents the position vector of every point on this line. As I keep changing lambda, I can vary it from minus infinity to infinity, anything. I will keep getting different points on the same line. Every lambda will correspond to a particular point. The moment I change lambda to something else, this point might change to something else, right? That's how I'll be able to create the entire line that I'm looking for. This was the equation of line passing through 2 points in the vectorial form.